Alright, in this video we're doing problem solving with integration. And what it really comes down to is that the integral of a rate equals an amount. For example, if you integrate your velocity, you get your displacement. Or if I was gaining $5 a day and I wanted to integrate that, it would give me the total amount of money that I'd got. Alright, data is collected about AFL fans entering the showdown between Port and the Crows. So we've got this function for the number of people entering the stadium. We want to find those three values and interpret our answers. R0, R20, and R80. So what we want to do is graph this. These rate questions are pretty much always calculator questions. So I've got the function in there. That was just in graphing mode on the calculator in menu there. And we've got to figure out what our window is. So if we're talking about minutes since 5 p.m. and people entering the gate, I'm thinking that could go pretty high up. So it's 0 to, maybe the gates will open like an hour or two before the game. And then you've got the game itself where people may be entering. So let's go 4 hours. Let's go 240 minutes. Y-min is 0 because I'm assuming people will always be coming in and this is people entering. And, well, there's sort of numbers in the thousands in that formula. So maybe let's try 1,000 for our maximum, see what happens. We're missing the top of the graph. So I'm guessing we're going to have to go a little bit higher than that. Let's try 3,000. And there we go. We've got the lovely graph there. So if we want R of 0, we can go trace at 0 and we go at 2,500. So there are 2,500 people per hour entering at 5 p.m. That's how we interpret the first one. R20, so trace at 20. You got 919.6, or I'm going to round it off to 920 people per hour entering at, and this is time in minutes since 5 o'clock, so 5:20 p.m. And then R of 80, so I'm going to go trace at 80. And we're going to get 45.8 people per hour entering. Now 80 minutes after 5 p.m. is 6:20. All right. Now this is an approximate as well because I've rounded. Find the total number of fans who have entered by 5:30. Now this comes back to the integral of rate is amount. So this is going to be, so the total is the integral from 0 to 30, so that's 30 minutes of the rate to t. And that's something we can do on the calculator. Gsolve integral from 0 to 30. Now you can do it by hand as well, but I'm not going to waste your time. 38843. By the way, I'm hoping this graph entered. I'm hoping this graph sort of makes sense. It's like tool at the start because everyone's going to want to enter when the gates open, and then it gradually tapers off as people have made it to the game and stuff. Find the number of fans who entered the stadium in total. Now this one I've intentionally done is a little bit tricky. We've got that it's the integral from 0, but where do we end? Well, we could go as long as we want. We could go up to infinity. Now in the real world, I'm not expecting any fans to be entering the stadium at midnight. I mean, the game's probably over, but in theory, we could go up to infinity. So that's the total. And you could work this out with like a full-on conjecture and stuff and do it by hand. But I'm going to go Gsolve integral from 0 up to, I think our window was up to 240, and that'll do the whole thing. 49999.6927. And maybe I'll make my window even bigger. So I'll make it go to like 10,000 minutes, which is ridiculous. But if I do the integral there from 0 to 10,000, I'm expecting it to be 50,000. So 50,000 people. That was a bit of a tricky one there. Upon entering the stadium, some fans realized they accidentally attended a Crows game. I don't know who would go to a Crows game. Due to this, they decided to leave early, of course, because they couldn't stand the sight of the Crows. The rate of fans leaving early is given by that. Find that. Okay, so it's R take S, and it's from 0 to 30. Now, let's get our window back to normal first of all. So we'll pop it back to 240. That was R. And we're going to be looking at S as well. So we're going to graph that 200 e to the power of minus 0.02, and then we'll put an x on there instead of t. So graphing both those, there we go, we got that red line. What I might do is just shrink my x window down a little bit. So maybe I can go 120 or something like that. Okay, so you can see the graphs do cross over eventually. The red one is a little bit higher up at the end. But we want to find the integral of R take S. So a nice good way to do this is to use the mixed integral function. And essentially what we're doing is we're finding the area between the two. So I'm going to type 0 for my lower bound and 30 for the upper bound. And you'll see the calculator will think about it for a second. And it's got that integral there. So this is 34331. Okay, and that's an approximate, and I should round it up to 2. So that's approximately. Okay. Now, notice that by 530, 38,000 people had entered. And when I do this integral, I get that, which is also a number of people. So this is the people in the stadium at 5:30. And I'm just going to make a little note here above the starting amount. You can sort of assume that there were 0 people at the start because like the gates weren't open yet. But in general, if you'd already started with a number of people in the stadium, the integral only tells you how many more people came in since 5 o'clock. Sort of like the plus C issue with integrals. Okay, so if you want to interpret it, you could have, we learnt before, 38843 came in. And that was the integral of 0 to 30 of R. And you can also interpret 0 to 30 of S being the people leaving. So we'll work out what that number is in a sec. But then the remaining was that number we just worked out, 34332. So just for completeness, I will just quickly calculate that integral. So we're going to go integral there. And then we're going to go down to the bottom function, 0 to 30. And it's 4512. And I'm hoping those numbers together make sense. 38 take 4,500 is about the 34 that's left. In minus out equals remaining. Cool. All right, find the time where R and S are equal and we'll interpret our answer. So that's going to be Shift G solve intersect, and it should find it for us. 84 and 37. So 84.2. And it is 37.2, I think. So that is our T value, and that is our R or S value. Because R equals S, it could be either one. And we can interpret this. So at 84.2 mins, so this is 6:24 p.m. The number of people entering equal per minute. And I guess I should have, I guess number is appropriate. It's like a rate equals the number of people leaving per minute. This is 37.2 people per minute in both cases. So I'm just going to say probably the rate / number there, just to be extra clear. So that's how we interpret that one there. Now the game starts at 6:30. How many fans are in the oval when the game starts? So this is just straight off an integral. So this is the total. It's the integral from 0 to 90 because 6:30 is 90 minutes after. And we have to start from 5 o'clock. And this is R of t. So that's in minus S of t. So that's out. So this is very similar to the question we did up above here. We just need to go up to 90 instead. So Shift G solve, we're going to go across to integral, mixed. Let it think for a second. 0 for the lower, 90 for the upper. And we'll see what we get. So, all right, now when you work this out, the calculator actually spits out two slightly different numbers. Yeah, the first one is correct, 41098. I want to talk about why that is and why we're getting two different numbers. So basically, this is S, and if I draw a really overemphasized version of it, this is R. It doesn't really look like that on the calculator, but they do cross over right at the end of their range. Now, basically, if we get the area under S, that area is entered. And if I get the area under R, that blue area, that is the amount that have left. So I'm not actually looking for the total area in between the two. I am actually looking for the integral of S take R. So basically, when you work it out, the area that we actually want is that. And the other area that we want is that. But we do want to keep that positive, and that will end up negative just when we do S take R, because R was on the top in that last bit, it will come out negative. And the reason is because that bit there is that special number 84.2. And then anything after that is more leaving than entering. And this is more entering than leaving. Okay. So what we do to interpret this is it's 41098 people. That's how many are there when the game starts. And we actually did interpret this before as well. So, well, sort of. 50,000 people entered the stadium, but you don't end up with 50,000 people in the game because there's only like 41 because some left. Now, there's another question that you could ask yourself about this. You could ask sort of when the max number is in the stadium. And basically what this would be, it would be 0 up to 84.2 of S take R. And the reason I've only gone up to 84.2 is you want to capture all this time when more people are entering than leaving, but you don't want to get any of the time where more are leaving than entering, because then you start losing people overall. So we could work out what this is. T there. And your calculator can just tell you that value as well. It should be a little bit bigger than 41,000. So we're going to go there, mixed, 0. We'll have a think. 0 there, and 84.2 there. And that should give us a number. When it thinks about it, 41113. 4113. 4113. 0.9, so that's up to 4 people. So that was sort of the most that were ever in the stadium, just in case you're wondering. Okay, now last question. Let L be the total number of fans leaving. Now this is both leaving early, like what we saw before, but it's also leaving at the end of the game. So this is just the total number who have left overall throughout the night. And as you can imagine, everyone's going to leave at the end of the game. Like nobody hangs around in Adelaide Oval until like 2 a.m. after the game's finished. At least I hope not. So the answer here is 0. Right? That is entering. That is leaving. And you would hope that there are no people left once all is said and done. Anyone who came in went out. So that integral would have to equal 0 without working anything out. Now, when you interpret all of these numbers in this question, I really just want to point out again, any of these numbers are people above the starting amount. Now, in our case, for a football game, you would expect that there were 0 people watching the game before the gates opened, because like, how did they get in if the gates weren't open? But with integrals, you've always got this pesky plus c with integration. So if there was like somebody hiding out and living in the stadium, there wouldn't be 0 people left. There'd be that one person left who was still hiding out in the stadium. So you just got to be conscious. Anytime you interpret a number like this, it's above starting value.